Let's do the speed of longitudinal wave. Okay, now you know that in a longitudinal wave, it goes as compressions and rarefactions. That means we have to talk about the change in the volume and the bulk modulus comes into play. Okay, so here let's try to understand how it works. See, the first one what we have is that the change in the volume, or you can say that volume of the medium that changes, we can represent it as delta V by V. Correct? And the change in the pressure, we can say it as delta P. And B becomes the bulk modulus. Okay, B becomes the bulk modulus. So now what we have? B is equal to delta P divided by delta V divided by V. Correct? Now in this, what we understand is that whenever we have the bulk modulus part, see, a very important part is the density. Rho being the density. Okay. So the speed of this particular part. So look at the screen here. What we are going to understand is that let V be the velocity, or you can say the speed. Alright. Now here what we have, velocity V is proportional to B power A rho power B. In the sense, the velocity depends on the bulk modulus and it also is going to depend on the density of the medium. Okay, two things, because bulk modulus already has pressure and volume as the parameters. That means the speed of a longitudinal wave in a medium depends on pressure, volume, density. That's why we are taking bulk modulus as well as the density. Okay, let's do the dimensional analysis method here. Again, we introduce a dimensionless constant. We can say V is equal to K into B power A into rho power B. Again, dimensionally V value, or we can just write it here. Velocity V is given by m0 L1 t minus 1. Next, bulk modulus B is given by m1 L minus 1 t minus 2. And density is what? Mass by volume, correct? So since it is mass by volume, it's going to be m1 L minus 3 t0. Fair enough? Now let's do the math properly. Velocity V, so you have m0 L1 t minus 1 is equal to, next is the bulk modulus, which is going to be m1 L minus 1 t minus 2 power A m1 L minus 3 t0 power B. So you get m0 L1 t minus 1 is equal to m power A plus B L power minus A minus 3B t power minus 2A. This is what we have, equating the powers now, correct? So what do we get? First is A plus B is equal to 0, very simple. Then you have minus A minus 3B is equal to 1 and minus 1 is equal to minus 2A. Take the last equation. You will get, if you take minus 1 is equal to minus 2A, minus cancels, A value becomes half. See, once you have A value as half, substitute this in the first equation. We get A plus B is 0. So what do you get? B is equal to negative half. We got the value of A and B. Now substitution, that's all, very simple. If you are substituting this, remember you have to substitute for the equation V is equal to K B power A into rho power B, correct? Substitute V is equal to K into B power half rho power minus half. Okay. Now what do we have? V is equal to K into root of B divided by rho. Correct? Mathematically, this is the formula what we have. Correct? This is the formula what we have mathematically. But practically when you do it, K value becomes 1. So the formula becomes V is equal to root of B divided by rho. This is the speed of a longitudinal wave. Remember, whenever we have speed, the bulk modulus changes, which represents that during compressions and rarefactions, both the pressure as well as the volume are changing. Okay, the speed of a longitudinal wave depends on all the three, that is pressure, volume, density of all the three, all the three parameters of the medium. Here what do we have? This is the speed of a wave, whatever we just did the derivation here. This is the speed of a wave in a fluid. Okay, suppose if the longitudinal wave is traveling through a solid, then the formula changes slightly. Okay, then the formula becomes V is equal to root of y divided by rho, where y is the Young's modulus of rigidity for the material. Alright, this is the formula for the speed of a longitudinal wave in a medium. So we did speed of a wave in general, V is equal to f lambda. Then we did it for a transverse wave, and now we have done for longitudinal wave. Okay, now in the next video, upcoming videos, we'll calculate what is the speed of the sound and how we are going to calculate all these things.